Hello everyone, this is MG and welcome to another. Hey, can I call you back? Hello everyone, this is MG and that's it. Let's go. Hello everyone, this is MG and welcome to this video and also to this Azure Machine Learning Workspace. So firstly, before going to the details, what we're gonna cover in this video is how we can leverage GitHub Actions to create actually our CI/CD pipelines to trigger each step of our machine learning process to utilize and create an end-to-end MLOps solution. Let's make it simple. If you don't know what is Azure Machine Learning Workspace that I have opened here, or if you don't know what is Azure MLOps, make sure you check the MLOps video series on Azure that I've created. I'll actually add this right now on the top right side of this video, and also I will add the list to the video description. So in that video, there's a 10-part videos that we have already covered how you can use Azure DevOps as your not only source control but also a place to create your continuous integration and continuous deployment or CI/CD pipelines on for your MLOps, which is basically the purpose is creating those pipelines to be able to push a machine learning model from development to production. We create the model in a dev environment, we go to a staging or non-prod environment, we validate the results and performance of the model, and then we deploy in production. So through MLOps, we were able to actually automate this process. As soon as a data scientist push a new code to the source control, that means, for instance, there is a retraining or training a new model is needed. So it should automatically trigger my training pipeline to train the model, and as soon as the model is, let's say, registered or approved, then it should be deployed to staging or production environment. So not what we're gonna do in this video, we're gonna do the same exactly what we did in Azure DevOps, but now instead of Azure DevOps, we want to use GitHub Actions for doing all those triggering mechanisms, training our pipelines or CI/CD with GitHub Actions and using GitHub as a source control instead of Azure DevOps repository as a source control, to do the same thing but through a different manner and just a manner of tool and some minor changes. Alright, so let's start with the GitHub code that I'm going to share with you. Alright, so here's the GitHub template that we have the codes here. I'll add the link of this GitHub to the video description. So basically what we have some codes to create first the infrastructure. You need Azure Machine Learning Workspace. If you don't know what is this Azure Machine Learning Workspace, which is a machine learning hub in Azure for data science team to collaboratively develop their models, to register their models there, and even deploy the models there using Azure ML platform. So if you haven't heard about it or haven't checked that, again, if you watch the Azure MLOps video series that I added, it has also an introduction about Azure Machine Learning. So here I'll come through this. What is this infrastructure code and how you're deploying this Azure Machine Learning Workspace in your Azure subscription and the resources needed. But what I'm gonna start with is a potentially new concept for you that you might be also curious to know more about it as you're watching this video, which is GitHub Actions. So what is GitHub Actions? So in order to understand GitHub Action, there's actually a nice introduction and a video about GitHub Actions, but in a nutshell, let me magnify this. When you have your source control, let's say your GitHub, which is you have the main branch, all your data scientist codes are there, your training and deployment codes are there, your Python codes are there, for instance. And then usually as a data scientist, I'll clone this main branch to a feature branch of my, let's say, MG feature branch. I do the changes, develop some new codes, let's say new model with new training codes, and then upon approval and testing, then it can be merged to the main branch, so rest of the team can use it and we can build on the top, because this is the new version of the solution of our production that MG has created, right? Within this process, when you clone this main branch to your branch or feature branch, and when you are happy with the final editing, you want to push it back to the main branch or create a pull request, these are some actions you're doing. I am cloning the main branch, then pulling the codes, so I'm pushing the codes, doing a pull request to merge it back to the feature main branch. Each of these actions can trigger a pipeline in GitHub using GitHub Action. And this is what is called GitHub, to actually control this mechanism or do some workflow, do some CI/CD pipelines, and trigger those based on the actions that I'm doing here. If I actually move the video forward, here are a list of the actions available. You can see based on a pull request, as I just mentioned, as soon as you do a pull request to the source control, you will trigger a pipeline using GitHub Action. Or when you push the code, it will tell, you will tell to GitHub Action that, hey, as soon as someone push the code, trigger this pipeline. Or when the release is over, or based on a schedule, based on some actually webhook request from an external call that we're gonna actually do this for this video, trigger those CI/CD pipelines or actions in GitHub. So now then the question is how we define this GitHub Actions. So in your GitHub or source control, there's a folder named as GitHub-workflows. This is the place that I'm defining my actions that I'm gonna do. How we're gonna start actually develop our process or MLOps here is, as soon as a data scientist do a change in training code, we want to have an action item that, hey, trigger that train model.yaml file, which is basically telling that my pipeline that, hey, go grab this new code and train a machine learning model, because there is just a new training code that has been added with the data scientist to this repository. So let's check it out, how that works. This is the way that I am defining my GitHub action, and I'm telling that as soon as someone push a code, let's say a new training code, so that's the triggering mechanism on a push, and this is the path of the file, go ahead and let's say trigger, do this list of the action items. I'll come to this, but I want to pause here. So I mentioned that on push, as soon as someone push the code, we will do these jobs or steps. Also, you can have multiple triggering mechanisms. Here again, I'll come back to this. Let's say if in Azure storage, if someone delete a blob or create a blob, that's an action item as well. Also, based on any of those types, trigger this pipeline as well. So then let's say the model is, this pipeline is triggered because on push, someone just pushed a training code and we want to start actually training the model based on the new code, right? So what we do is, as soon as you trigger, this is the job you need to do. Hey, GitHub action, go ahead, grab an Ubuntu machine. You can even change the Ubuntu version here. And these are the steps that you need to do. First, as always, you check the repository, just check out, make sure it is registered with the action items. Then, of course, for training my model, I need to connect to my Azure Machine Learning workspace. And it will use an action item called Azure-ML workspace. This is actually defined in GitHub Action Marketplace, and you do not need to recreate and say that, okay, I'm telling GitHub Action connect to ML workspace, but how? So on backend, someone has defined this how answer that can let you connect to ML workspace. So you do not need to create that backend mechanism again. Just enjoy that GitHub action created in the marketplace. Now you might question what other action items has been created for Azure Machine Learning in GitHub Action. I'll come to this, but as of now, this is one of those that will let you connect to your ML workspace. But as you know, for connecting to Azure Machine Learning workspace, you need some credentials. What is the subscription, resource group, token stuff, right? So we need to define those as a secret in our GitHub. and I'll come to this how we define that. And that's it. Then afterwards we want to trigger a run. And what is that run? Training run. How we can do this? Another step. And what we use as an action item is AML run. This is another GitHub Actions that has been developed in GitHub Marketplace that will let you trigger a run or execute a code in Azure ML with just calling this. Similar to this for connecting to Workspace, and now I'm running. And again, for running something on Azure ML, you need to have access to those credentials to be able to authenticate this to actually Azure Machine Learning Workspace. So now at least you understand the flow of GitHub action item and the steps that we need to define, some of the actions that has been developed in Marketplace that I talked about. But do not forget that we need to have these secrets added to this GitHub. That I'll show you how you do that quickly. But before doing so, let's finish the action item here first and the YAML files that we have. Let's say now we have trained the model. Now, as soon as there's a new model that is trained and the run is complete, now I want to actually deploy this model, right? So for deploy model.yaml, you can see that I want to trigger this when that run is completed. And you might question that, well, what is that trigger type? How does GitHub Action knows that my run is completed? Well, if you pay attention to this, you will see that the trigger type that we have for this is something called repository dispatch. That's actually a way that you can trigger this based on an external event. Here, what we're gonna do, and I'll come to Azure to show you, we have actually a mechanism that has been created by Event Grid, Azure Function, and Azure ML, that when a run or training run in Azure ML is completed, with using Azure Function, I can call my GitHub API, and tell that to my GitHub, to this repository that MG has, go ahead and trigger this. So that's through a webhook actually. And that's a very powerful tool. So just telling you that you just don't need to trigger anything with just pull request, push, or release. You can have some external trigger mechanism as well for your GitHub action. And then the same thing, I want to run Ubuntu, the same thing that we talked about it. It will actually check some of the payload of the data coming from the previous run to make sure, let's say you have an experiment name, you have the run ID, and check out in the repository the same thing that I talked about. I told you that you need to connect to Azure ML Machine Learning, the same GitHub action. And also something new here, I need to create a compute, right? Let's say you want to run over a compute cluster or compute instance. So basically you need to create a compute machine inside Azure ML. That's another action item that has been created in Marketplace. You just call it, and using this, and of course with having the credentials, you will be able to create a compute in your Azure ML through this GitHub code that is running on GitHub action. And then we register this model. Again, another Azure ML register model that you can basically register the model using this action item, and then deploying the model using ACI. There's a JSON file that we have the configurations of the deployment, where you're going to deploy, let's say on a container instance on Kubernetes, or if it's Kubernetes, how many nodes, so on and so forth. And I'll come to this. This is actually, let's say, for staging or testing deployment, we deploy on container instance. But then for production, we want to, let's say, deploy using the same action item over, let's say, Kubernetes. And then I have a configuration file for my Kubernetes in my repository. I'll show you, and you're good to go. Then I want to echo some results in my run. That's it. So there's another one left. This is actually my deployment. And what I'm going to do here is, before even training the model, deploying the model, I want to deploy the infrastructure. Let's say there is no Azure Machine Learning Workspace in my subscription. I told you we need function, Azure Function, Event Grid. I'm going to tell you the reason why, but we need them all created. How? Then in this file, also make sure you change this Azure resource group to the resource group name that you want to have in Azure ML. This is my resource group name. You will change it. And then what does it do? It will connect to Azure using the credentials that we're gonna add. and then it's an inline script telling that go ahead, create these services and infrastructures from the deployment JSON file that I have, and we will see what it's going to be deployed based on what has been defined in these JSON files. And that's it. So coming back to my template, so what you need to do first is actually creating a service principal. And as if you ask why we need to create a service principal, the reason is we want to have this service principal as a way that GitHub can authenticate to my Azure Machine workspace, right? So in order to create that, here's an easy command that you can do. If you're using Azure CLI, create a service principal or SP, and this service principal need to have contributor role over the scope that I'm defining, or over the resource group that we want to deploy Azure Machine Learning over there, to make sure that this service principal has enough permission to give that permission to GitHub to get connected and do the stuff that we're gonna do over Azure ML workspace that we talked about, which is training a model, deploying a model, so on and so forth. So I copied that already, and then I went to my Azure portal and just click on Cloud Shell. It will open a bash terminal for you, and I just paste that command, and of course you need to change it based on your requirements here. So I give it a name to my service principal. You can give it anything you want. Role contributor, make sure that's contributor, and a scope subscription, and here you should have your subscription. I just removed mine, but basically what you need to add here, let's say 1 2 3 4 5 6 or whatever your subscription ID is, and then resource groups, and here's a resource group name that I'm going to deploy these infrastructure. And then when I executed that, it gave me actually some information that I cannot really show you because there are credentials. For example, what is the client ID, tenant ID, what is the key of that service principal. It will basically give you a final result in a JSON format. Copy them, and as soon as you copy them, this is what you need to do. So this is something similar to what you see. Just copy them, whatever you have. And this is the secret that I told you that you need to add in your GitHub, that your GitHub action can use them to execute those GitHub action items that we just talked about it. So how you can do this, you need to add this as a secret in your GitHub. So in order to do so, go up, click on settings, then go to secrets, action. I have already created mine, but this is how I did it. New repository secret, the name, make sure this is the name you will choose, Azure credentials, and then paste the values or that JSON, similar JSON format that you copied, and paste them here. Add secret, done, you're good to go. All right. Now the second thing that we actually need to create and also save that as a secret in GitHub again is actually GitHub token. And the reason is that also from Azure, we want to authenticate and deal with our GitHub here, right? So we need to have that GitHub token that will allow Azure resources to communicate. So in order to do so, go to your settings, and then all the way developer settings here, and then personal access tokens, and then just generate a new token. As soon as you created yours, also that's a credential, that's why I'm showing it not here, make sure you save yours, copy that, and then the same thing, create that as a secret. Remember how we did it? Don't worry, I'll come back to this. Let's go in back. Let's say I have copied that my token, go to setting again, the same thing, go to secrets, action, create a new one, and call it path token, and then enter the value there, and that's it. Click on add secrets, you're good to go. So coming back to my repository here, and also before I forget, when you create your token, it will ask you how much power or permission you want to give to this token. Make sure to click on the select or on the repo side, as it has been mentioned in the picture, to make sure that your token has access to this all capabilities of repository. And that's it. So After creating those credentials and now we have them as a secret, what we're going to do, the same first thing, we want to deploy these services on Azure, the infrastructure. In order to do that, go to Cloud Azure folder, and you can see, remember I told you when you want to deploy the model on container instance, on Kubernetes, we need to have some configurations. These are all has JSON here has been created. For example, for let's say for deploying the model over container instance, this is the name I'm gonna give it, and that's for sure we need a source directly for inferencing. This is the place in my repository. Of course, in order to score a model, as you know, you need a score.py. That's the place here, and that's the conda environment of my deployment, and some other configurations that even you can add more. So, but the first thing that you need to change, go to workspace.json. You'll see that name. This is the name of the Azure Machine workspace. You can change it. For the resource group, change it to the resource group name that you have already created in Azure. And remember, when we were creating that service principal, we gave that service principal contributor permission to a resource group. That was the same resource group. That's it. Then the second thing that you need to change, I told you, but I'm gonna mention it again. Go to your GitHub workflow, setup. Also here, you need to change that as well. Let's say I'm gonna change one. Let's say here I want to change it to GitHub OHDemorg02. I know that doesn't exist. I'm not going to finalize the commit, but there's a reason why I'm showing you here. Let's say start to commit. When you change this part with the Azure Resource Group name, click on create a new branch. It will, as you know, it will propose change as a new pull request, and you should merge it. And as soon as you merge the request, which means that you have finalized this change and name and you have added to the main branch, this is what I did, and that's why you saw actually that we canceled this. This is the reason that why you see my resource group name has been added here, because I merged the changes and it came to master branch, and you see it has been updated by MG. What's gonna happen? It will start to trigger something. And as you might know, it will start to actually trigger based on push. So all this YAML file, which is creating my infrastructure, will be triggered as soon as I change something here. Because it is telling that basically, if someone, let's say MG, come to this file, to this path, push anything new, then trigger all this pipeline. And I did something, I changed something, and it triggered this, and what happened? Well, it logged into my Azure using the credentials we saved, and then it started to deploy these resources from these JSON configurations that I have in infra folder. Let's check out the infra folder. Coming back to my infra, these are the services that I have. Let's say the core deployment. I'm not going through that, but it's creating Azure ML, storage account, event grid. I'm gonna tell you why we need this Azure function, computes, so on and so forth. And in order to see when you create that change, it will automatically start to trigger this. Go to actions. This is the first thing that happened as soon as I did a change. I changed that workspace name and it triggered this setup.yaml. I clicked on that, click on deployment, there you go. You can see it log into Azure. It is actually running that setup.yaml, which was log into the Azure and then deploying the services. I didn't trigger it again because actually I have it already, so it's gonna redeploy them again and also take time. So I did it before recording the video to save the time. Perfect. What will happen after finalizing that deployment and having that action being done? And you should be able to see this in a green color, which means your deployment is over. Mine took almost 4 minutes. This is what you will see. I'll go to my resource group that I have deployed everything. There you go. And here are all the services. Some of them I created them before, so don't worry if you don't see all of them. This is an old resource group of mine, but there are some new stuff added here. One of them is this one actually. This is the name, remember, we had in workspace.json. This is new created. This event grid will be created, the Azure function will be created, app inside, container instance, all of them will be created for you. Perfect. That means at least we have the infrastructure ready for a model training, model deployment, and having our action items in GitHub for having the MLOps solution. Now, what is next? So the next is, now we have the infrastructure ready. Let's see, as a data scientist, let's say I have created a new model training code and I want to push it to this master branch to let everyone knows that I have come up with a solution, and then it should automatically start to trigger my training pipeline as soon as my code has been approved by, let's say, team lead, right? So remember that in our GitHub action, we finished infrastructure using this, and now this is the training action. Let's see what was actually the triggering mechanism of training. It is telling that as soon as someone, a data scientist, anyone push a code to any file under this folder, it should trigger my training. So let's check out this code folder. Code, there you go. That means me as a data scientist, if MG add any new code in training folder or code folder, it will actually start the training pipeline. Let's do that actually. Let's say this is the train.py. This is actually a line that I added. Let's say this is a new file I want to change. You definitely don't change the code in GitHub. You have your environment, you have your Azure Machine workspace that you change the code, then push it to GitHub, or using, let's say, your IDE, Jupyter Notebook, VS Code. Here, just showcasing you how the mechanism works. I want to change it from here. Let's say I want to delete this test file, test line. What I'm gonna do, I want to create a new branch, propose the change. Hey, I'm coming with a new solution. Let's say this is a test, and I want to create a pull request. Then let's say someone gonna come and check this. Oh, this seems to be good, perfect. I see that MG has created something that makes sense. We validated that, so we're gonna merge it to the master branch. So I'm gonna do that right now. Confirm the merge to update this file in the master branch. Done. This will trigger now my training pipeline because MG's code for training model has been approved. Let's check it out. So in actions, I should see a new action item created. Someone updated the train.py, which is me. And there you go. If I click on the deployment, you'll see that it actually triggered the deployment again, because in the triggering mechanism we said that if someone changed any code, trigger the infrastructure deployment, which shouldn't be the case here, but just to showcase you that it works. And then coming back to the actions, oh, never mind, I think I was in the right one. So again, we updated train.py deployment. This is, sorry, not the infrastructure deployment. As you can see, it knows that someone changed the code and the code of training is approved, so it automatically is connecting to the Azure ML workspace and then submitted my training run. I actually did this before to save the time for this video, so I'm going to show you the results. Let me go back to the action item. Let me check where it was. I think this one. Yep, there you go. I saw that the submit training was over after 10 minutes. So I just wanted to check, make sure that training mechanism has been working properly. And as you might question, where is the training Python code? Everything is here, and we're referring everything inside this GitHub code. So you can see, for example, train. This is my train.py. I'm not going through the training Python code. That's just a very simple model from scikit-learn data to do some testing and validation, and that's it. So then what I did, I went to that actually Azure Machine workspace that we created using the infra code of this GitHub. Let me go through it. Here we go. That's the same workspace. And then if you go to the experiment, you will see that there is one already queued. This is the one that we just actually enabled using GitHub Actions, which is running right now. But the previous one, I already did it and it worked and it was completed. And you can see actually even after that the model was registered. If I go to the models, there you go. I ran it 2 times, Now a new model has been registered for me using a compute cluster. And you remember in Azure GitHub Actions, we had also a compute cluster creation added to our YAML file. There you go. That's actually a cluster created, and as you can see, it is resizing because we just triggered training using GitHub Actions, and it is trying to launch this cluster up again to start the training, which is basically this action item here, which is running. Perfect. And then what's gonna happen after, when the training is over, the deployment action gonna be started. Let me come back to this again. In my workflow, we just triggered this, it worked, and then when this one is over, it will automatically trigger the deployment, because the deployment is gonna be triggered based on when the run is completed. Now, here is the tricky part. How does GitHub would know that my training in Azure ML is completed and it will trigger this deployment file? That's a very good question. In order to explain that, let me open my pane. There you go. So basically, when you have your Azure Machine Learning workspace, let's say here is my Azure ML workspace, right? Oops. So in Azure ML workspace, you can actually set up some triggers, and I will show you actually how. And there you go. Actually, when, for example, something fail or succeed, it will actually send you a notification on your email. Let me close this. For example, you can set up triggers based on what? Let's say when a model is deployed, for example, or one that is trained, or anything else. I'll show you the different type of triggers. When a model is deployed in the Azure ML workspace, we want to start a triggering mechanism, and I will show you how we define this. This is gonna happen through event grid. That's an Azure resource for triggering mechanism, and it is basically saying that check out this ML workspace. When a model is deployed, when the run is complete, go ahead through webhook, trigger an Azure function. Let me actually create another box or make it circle. Let's say here's my AZ function. Then what does that Azure function do? As you know, Azure function is a service, is a serverless solution that you can enable run any function there, let's say using Python, and then trigger that function. So we are telling that when the run is over, through event grid, trigger this Azure function. And what does this Azure function do? That's the nice part. It will go ahead and trigger my GitHub action item. GitHub action through deployment. That's how basically through webhook we are telling to GitHub action from Azure function. It will call the GitHub API to tell that, well, hey, there is a model, just the training is completed, run is over, and this Azure function will listen to that from event grid and then call my GitHub action item that's the time you should run the deploy.yaml, which is this file. And when I said repository dispatch, that's actually external triggering mechanism coming from Azure, which is the Azure function. That's why I told you why we need event grid, why we need Azure function to enable this. And then the same thing, it will deploy the model in ACI and AKS, done. So let me show you how it worked. Then when I go to models, I saw that, let me go to the endpoints. Yep, there you go. I see that I have model that has been deployed not only in container instance, but also this model is also deployed on Kubernetes. And if you click on any of them, there's a score URL, you grab it and you call it to do the prediction. Your model is now deployed in staging and production. You saw that how with GitHub action item, the process was automated. As soon as I changed the code in a specific folder, it triggered my pipeline, my training pipeline, and now even my deployment. If you have watched the Azure DevOps MLOps video series on Azure, I explained the same thing in a more thorough manner in almost over 10 videos to do the details of these CI/CD pipelines in Azure DevOps with having some approvals. You can get it much more complex and complicated. This is just a very high level and simple example. You can similarly do the same thing in GitHub action items. And if you go to Azure, if you go to GitHub Action Marketplace, you will see potentially in future some even more action items that can be created for Azure ML using GitHub Actions. As of now that I'm recording, and that also has been added to this repository, here are the action items supported for Azure Machine Learning, which means you can trigger an action item based on these AML changes. Connect to AML workspace using GitHub Action. We use this, creating a compute instance, submitting a run. This is how we actually submitted our training run. Registering a model using GitHub Action, and even deploying the model. This is also, I think we almost use all of them in this example. Now, talking about that event grid to setting up a trigger for AML workspace, just quickly showing you that as well. This is your machine learning workspace, right? But before coming to this, let me click on my Azure Machine workspace. There you go. Let me actually close that. There's a section called events. Click on that. This is the place you can set up an event. When you deploy this infrastructure, there's an event already created for you. You don't need to create this, but just show you that through webhook, this is what I talked about, telling that when actually a model is registered, there are actually more event types, not just register. We'll check this. Do something, which is calling an Azure function. How would I know it? Let's actually open it. You can see that based on some specific triggering, let's say when the model training is over, this event grid will actually call this URL. This is my Azure function. And this is an Azure function that has been created and deployed using that infrastructure code. If I show you that Azure function, let me check. There you go. And there you go. As you might be able to see, this is the same URI that we just saw in event grid now is in Azure function, which means that event grid is calling that Azure function, and this Azure function is also triggering my GitHub action. And that's it. Before finalizing the video, let me also show you my deployment pipeline when that triggering worked and then the deployment was over. So going back again to this GitHub and going to actions, I think that was the, yes, the run was completed, and that should enable the deployment. Clicking on that, there you go, you'll see that it registered the model, deployment on ACI or container instance, and then for prod it deployed on Kubernetes. And that's how I then came to my Azure workspace. You see that it is not created by MG, it is created by that service principal we created. And we gave that service principal to GitHub to use it to come to my Azure workspace and do this instead of me or anyone else, because we want to have automated without any interaction. So we need a service principal, not a human, to do all this deployment manually. And that's all about this video.
All right, I hope you enjoyed the video, and until next time, see you later.